Hello everyone, Jen to all. In this video lecture, I am going to record about the theory of automata and formal language. First of all, I want to tell you what is mean by the theory of automata and formal language. This is a subject which is running in 4th semester, and this subject is mainly a logic based numerical subject, in which we have discussed about lot of things. And the application of this subject is we have to use to design of compiler, in which we have to use to string matching and other types of matching algorithm. It is also used in artificial intelligence to processing the given string in the time frame. First of all, I want to discuss what is mean by theory of automata and formal language. This subject is currently running in 4th semester. A theory of automata and formal language is also known as theory of computation. Previously, this subject is known as theory of computation, but in AKTU, this subject is running with the name of theory of automation and formal language. Also known as the theory of computation is a theoretical branch of computer science. Tafl mainly deals with the logic of computation with respect to simple machine referred to as automata. Tafl is an abstract machine or abstract model of digital computer. It is the types of abstract model of a digital computer in which we have to hiding all the complexity and only show the essential part, in which we have to process the given language or process the given data in the form of on the basis of machine assumption. Tafl is a mathematical model. It is a mathematical model in which we have to set of input and we have to produce the set of output through which we have to process the given data. Automata oriented from the word automation, which closely related to automation. It is derives from the word automation, in which we have to give input and automatically the machine produce the desired output. This is the basic definition of automata. And what is the need of this subject? I earlier tell you that this subject is used in compiler design as well as artificial intelligence to string matching or processing the given string by using the desired machine. This is the application of Tafl, in which Tafl are used in artificial intelligence embedded system, but most widely used in application in the compiler construction. It is mainly used in a compiler construction. They check whether the language written is correct or not, because whenever you have to given a string and that string is processed by the given machine, at that condition we have to check the given language or given string is correct or not by using the given compiler or given machine. The next one is the automata enables scientists to understand how machine compute the function and solve the problem. This is also a basic concept of application of Tafl, in which automata enables scientists to understand how machine compute the function and solve the problem. The last point is the main motivation behind the developing automata theory was to develop method to describe and analyze the dynamic behavior of discrete system. Means we have to analyze the discrete system by using the different inputs according to the machine. This is the fundamentals of Tafl, in which we have to discuss about what is the basic components which is used to derive a machine or which is used to define a machine. Or you can say the fundamentals are those which is used to design a machine. And this is basic components are used throughout the automata, which may unit 1 or which may unit 2, 3, 4 or 5. Anywhere this fundamentals is used to design a basic machine on the basis of the given input. The first point is symbol. Symbol means what type of input symbol we have to use. A symbol is also called character, and in automata we have to use alphabets, number and some special symbol also. In special symbol we have to use dollar or we have to use hash also. This is the example of symbols in which we have to use ABC, that's alphabets, number 1, 2, 3, 4, 5, 0, 1, 2, whatever, but we do not use the negative number and etc. We also use the special symbol like hash or dollar, which is also used in the automata. The is the smallest building block, which can be any alphabets, letter or picture. We also use a picture to show the specific input. Now, the next one is the alphabet. It is a set. So, this set is denoted by sigma. That is also called input alphabets. Alphabets are a set of symbols which are always finite. Finite means we have to use a machine and we have a given language. And by using that machine, we have to process the given language on that machine. So, the string must be finite as well as the input symbol also must be finite, because I want a result. And for the result, the input must be finite. If the input finite, then we have to generate the output also as a finite. If the input is infinite, then result is discarded and that result is not predictable, so that we don't use the infinite language or infinite input alphabet. We always use finite set because I want some result, and if you want a result, then we have to must be use the finite input alphabets. Here some example on input symbol. We have taken sigma as a input set and we take 0, 1 as a input alphabet. Now the next one is the A, B. We can take any types of input, which may be 0, 1, which may be A, B, which may be X, Y, which can be Z, whatever alphabets you have used as a input. And the number of input also will be changed. Here we have take 2 input 0 and 1. We have to take 3 input 0, 1, 2. You have to take 4 input 0, 1, 2, 3, 4, 5, etc. So this is the main points through which we want to introduce the automata in the concepts of computation. The next one is string. This is the basic things. We want to define what is meant by a string. A string is a finite. Here also we have to use finite word, because I tell you we want a result, and when we want to result, the input must be a finite. If you give some infinite inputs, then we can't decide what type of output will be generated. So we have to use finite word here also. A string is a finite sequence of symbol from some alphabets. A string is generally written by W. Here we have to use W to represent the string, that is the last alphabets or last symbol of the alphabets, which in the letters A, B, C, D used as an input, and the last symbol is used as a denotation of a string. This is an example where sigma equal to A, B. This is the W1. W1 means a single string which is denoted A. W2 B, W3 AB, AB, W4 AB, BB, AA, BB, AA. This is our 4 strings. One is W1, second one is W2, W3 and W4. That means the string means from the input symbol, we have to concatenate A and B, and we have to generate a sequence. That sequence is called string. And the length of string may be any numbers, because sigma contains A, B. So from A and B, we have to obtain any sequence like this. And this sequence is called string. This sequence is called string. It may be BA, BA. It may be triple A, 4 times A. It may be 4 times B, like this. This all are a string. That means a sequence of symbol is called a string. Now, the next one is length. We have to define length on the basis of a string. In a string, the sequence of symbol is called string, and the length is the number of symbol in the given string. The length of the string W is denoted by mod of W. This is the notation which is used to represent the length of the string. I have any string. Consider S equal to AB. We want to find the length of string S. Then we have to write mod of S equal to 4. This 4 is the number of symbol in the sequence. Means the number of symbol in the sequence is called length of that string. This is the length of a single string W1, 1, W2, 1, W3, 4. This is the W3, W4, and W4 is 6. There are 6 symbol in the string W4. Now, what is mean by concatenation? This is the operation which is applied on two different string or two same string. We have to combine the given string. That operation is called concatenation. The concatenation of two string W and V, there are two string W and V, is the string obtained by appending the symbol of V to the right end of W. There are two string W and V. First we have to write W, then we have to write V, and this is called W dot V. This is the sequence, this is the concatenation of string. Here W equal to A1, A2, A3 up to AN, V equal to B1, B2, B3, B4 up to BN. We want to concatenate this two string W and V. Then we have to write W dot V, and the output of W dot V is, first we have to write the sequence of W, then we have to write the sequence of V. Now, and we can also find the length of W dot V, and the length of W dot V equal to length of W plus length of V. By using this formula, we have to calculate the length of W dot V. Now, the next point is reverse. Reverse means reversing the given sequence, that is called reverse. Here W is A1 to AN. Now, W power R is AN minus 1, AN minus 2, 3, and A3, A2, A1. This is the reverse of a given string. Next is a node which is on the basis of a string. An empty string is a string with zero occurrence of symbol represented as null. This symbol is called null, and this is the most important symbol which is used in the NDFA. And another point is, for alphabet A comma B with length n, number of string can be generated to power n. Number of string can be generated to power n. That means if we want to generate a string of length n, then we have to use formula 2 power n. This 2 is number of input. If the number of input is 3, then we have to generate 3 power n. If number of input is 4, then we have to generate 4 power n of length n string. If we want to change the length of string, that means if the length of string is 2, then how many string of length 2 is generated for input 2? We can write 2 power 2. What is the number of string can be generated of length 3? We can write 2 power 3. What is the number of string generated for 2 inputs A comma B of length 4? We have to write 2 power 4. So this is the formula which is used to find the number of string of length n. 2 power n. 2 is the number of inputs and n is the length of the string. When we have to change the length of a string, we have to change the value of n. We have to calculate the desired output. Now, the next point is sigma plus. This is also called positive closure, and that represents a set of all string except null R string. First, we want to define what is meant by sigma star. After that, we have to define sigma plus. Sigma star is and that represent the occurrence of certain alphabet for a given language, alphabets from 0 to infinite number of times, in which null string is also included. That means if we have to sigma equal to A and we want to write sigma star, we have to write null like this, then A, then double A, then triple A, etc. The set of 0 or more string is called sigma closure. And when we have to remove from this sequence to null, then we get sigma plus. If we have to remove the null, then we give sigma plus. This is the basic difference between sigma plus and sigma star. Sigma star is called clean closure, and this is the important points. This is an example in which we have to show how we have to calculate the sigma plus and sigma star. We take sigma equal to A. We want to find sigma plus. The sequence of string of concatenated using A. We take A as a single time, that is A 2 times, double A 3 times, etc. Sigma plus include null. That means in a sigma star, we have also include the null. Now, we want to define the term language. A language is a set of strings chosen from some sigma star. This is the sigma star. If we take some sets from this sigma star and we form another set, then that set is called language. Language is the set of or subset of a sigma star. Our whole sigma star is called language. We can say a language is a subset of sigma star. This is the main points. A language is a subset of sigma star. A language that can be formed over sigma can be finite or infinite. We can already explain it. If sigma contain a symbol, then we can form finite or infinite set of string. And if the set of string is also finite or infinite, then the language should be also finite or infinite. This is the relation between sigma plus and sigma star. Whenever we have to remove null from the sigma star, we have to give sigma plus. And this is the derivation of sigma star. How we can derive this sigma star? If sigma equal to A, we want to write sigma 1. That means set of string of length 1, and that is only A. Now, sigma power 2, set of string of length 2, that is only double A. Sigma 3, set of string of length 3, that is triple A. And by combining this through operator union, we get here we have also include sigma power 0, that's contain null, then that's contain null, so sigma power 0, and this is called sigma star. This is the main derivation of sigma star. I explain it. Sigma 0 means length of a string length 0, that means null, only null. Sigma power 1 means length of string of length 1. Sigma power 2 means length of string of length 2. Sigma power 3 means length of string of length 3, and dot dot dot. After combining this, we have to get sigma star. Now, I want to discuss what I mean by grammar. This point, the point which is discussed till now, this is covered the basic of theory of automata. Now, the next point is grammar. Grammar is derived from the language. A grammar for English language tells us whether a particular sentence is well formed or not. It tells about the rule of communication, where we have to communicate with other or communicate with a machine. We have to using the correct language or not, that is decided by grammar. Set of rule to govern communication is called grammar. Here the Typical rule of English grammar is a sentence or consist of a noun phrase followed by predicate. This is a sentence. There are two parts, noun phrase and predicate. Noun phrase is divided into two parts, article and noun, and the predicate, which are verb. Now, this is the symbolic notation. This is a symbol which is changed according to sentence. Here, article A, noun, boy, and verb, run. A boy run. This is divided into three parts, article, noun, and verb. That means how we have to represent a sentence in the form of grammar or in the form of sentence, we can easily translate it. Now, this is the grammar. This is the grammar G defined in the four tuple. Here, V, T, S, and P. This is the main parts of the grammar in which we have to discuss. V is a finite set of objects called variables. T is the finite set of objects called terminals. And S is the finite special symbol called start symbol. And P is the set of production. This is the tuple form of the grammar in which we have to represent the grammar. This is something different which we discuss in the next class. If any doubt till this point, you can message in the message box.